Now, Master's theorem for decreasing functions. Already we have solved some decreasing functions in previous videos. You can watch them. From video 1 to 4 we have seen. So from that only I'll take the example, then I'll explain you Master theorem. See, we have already seen that T n is equals to T n minus 1 plus 1 was order of n. T n is equals to T n minus 1 plus n was order of n square. T n is equals to T n minus 1 plus log n was order of n log n. These were the answers we got. Then also we have seen this one, Tn is equals to 2Tn minus 1 plus 1. We got the answer as 2 power n. We have seen this one. Then it means Tn is equals to 3Tn minus 1 plus 1 will be order of 3 power n. Yes, true. And if we have Tn is equals to 2Tn minus 1, same as this one, plus n if I take, then this will be order of n 2 power n. Like here, every time when whatever we have, that was getting multiplied by n. Now here whatever you have, that will be multiplied by 2 power n, because 2 is there, coefficient is there. Now your observation is more important. I have written some recurrence relation and their answers. So just you can pause and watch this one. You observe and spend time on this one. Now from this observation, now I will define the general form of these recurrence relation. Let us say the recurrence relation is of the form Tn is equals to some coefficient is there. So let us say it is a, t, n minus sometime 1, sometime 2, whatever we want we can subtract. So let us say b is subtracted. Plus here we are getting some value. As I have already discussed that this we take it as a theta or big O. We take a asymptotic value here. So let us call that as f of n. So we say this is the general form of recurrence relation. This is the general form of recurrence relation. In this we assume that a is greater than 0 and b is also greater than 0, and we say that f of n is in the form of order of n power k, where k is greater than or equal to 0. We assume that all these are, this is greater than 0, this is also greater, a and b, they are greater than 0. If it is 0, then it is no subtraction is there, right? And this also 0. If it is 0, then everything is 0. Now, let us observe here. Now here we get some cases. Here a value is 1. A value is 1. So if a is equals to 1, then what is the answer we are getting? Whatever is there at f of n, this one is getting multiplied by n. Whatever is there here, that is getting multiplied by n. So whatever f of n is, it is multiplied by n, right? So we say that f of n is in the form of n power k. So we say it is order of n power k plus 1. So if it is n power k, then into n again, into one more n again. So n power k plus 1. So that's it. Or in other words, I can also say that this is multiplied by n into f of n. In other words, this is one way of saying that. Otherwise, whatever the f of n is, see, this is log n log n. This is n into n square. This is 1 into n. So whatever the function here we have, that is multiplied by n. So n into f of n. Or in other words, if you say f of n is n power k, so you can say n power k plus 1 also. So this is simple for understanding. Next, we have seen one more thing. Here A is greater than 1, 2, 3, whatever it is. So if A is greater than 1, then what? See, it is 2 power n and this is 3 power n, and in this one, this was there. So this is multiplied by 2 power n. So whatever A is power n. So this will be A power n. And whatever f of n is, that is multiplied. So I can say f of n is what? N power k. So n power k into A power n. And here in this example, we have taken n minus 1 only. If it is n minus 2, n minus 3, if you are subtracting some greater value other than 1, then this will be n by b. If it is 2, then n by 2, A power n by 2. It means here I write, if this is 2, then this will be 2 power n by 2. So here I have two cases. One more case I will write. What if A is less than 1? Means it is not 1, it is 0.5 or 0.75 something. Then what is the answer? It is same as n power k. Same as n power k. So even I can say it is just f of n. So here we have three cases. Case 1, 2, 3. This is Master's theorem. I have explained from the examples, already we solved this. So by putting these here, we have observed and written the theorem. Otherwise, first you can write the theorem and take the examples. Following that theorem, you can write the answers. Once again, if A is less than 1, same as f of n, and we are saying if n is f of n is n power k, let it be n power k. If A is 1, n power k plus 1 means n into f of n. And if A is greater than 1, then f of n into A power n by b also we can say. Whatever f of n is into A power n by b. Either this or this, anyone you can take. Now by following this Master's theorem, you can solve any recurrence relation which is in this form, that is a decreasing form, this form. You have to spend some time on this one. There is no logic behind this one. So just you have to observe this and do some work by yourself, spend some time on it, solve these by yourself, then you can remember them. You at least spend some time, at least one time you write it, then there are chances that you remember. Just by watching you cannot remember this one.